Hey everyone, thank you for watching StarMorph, where we talk about artificial intelligence and web development. Today, I'm really excited to introduce you guys to Jerry, who is the founder of LlamaIndex, a tool to connect large language models to external data. So thank you very much, Jerry, for coming on today.
Thank you, Dylan, for having me. Super excited to be here.
Absolutely. Before we kind of dive into what is LlamaIndex and how people can start using it and building with it, would you be okay with giving a little background about how you got into building this tool in the first place?
Yeah, that sounds great. So I started building the tool back in November. I've always been very interested in AI, systems, startups, all those types of things. And so my previous work experience included spending a few years at a Series B startup called Robust Intelligence, where I was leading the ML monitoring team. And then before that, I spent some time in AI research at Uber ATG. And I also spent some time before that as a machine learning engineer at Quora. I've spent some time in like machine learning across like recommendation systems, like computer vision, a little bit of NLP as well. And so I hadn't really like fully dove into the like whole GPT-3 wave. Around that time, like Dolly was there, like Stable Diffusion was out, and like people were playing around with building applications on top of GPT. But I was just starting to get into that. And I think one of the first things I ran into as I was thinking about building these applications was I was trying to feed this amazing piece of technology my own private data. I was trying to feed it our customer conversations from my previous company, and then I was trying to figure out how to best leverage this tool to be able to synthesize insights from the private data. And I figured a lot of the abstractions that I was building were probably things that everybody building applications would need to solve anyways. And that kind of motivated me to start a very initial tool. And at the time, it was called GPT Index. And I've since renamed it to LlamaIndex. But the idea of the tool was basically to store some sort of like external memory for the language model in some sort of data structure that the language model could be able to like look up and reference this memory for later. It very much started as a design project, really, but it seemed like a structured chord with like people that were also trying to build applications. And from there, it evolved pretty quickly, and now it's kind of like a full-fledged toolkit that people are using to actually build end user-facing applications.
Oh, that's amazing. It reminds me, I've heard on Y Combinator and things like that, that sometimes the best way to find a real product market fit and solution is by building something that you need, right? And yeah, it turns out that I think a lot of people are looking for exactly what you just described, the ability to bring in their specific data into these bots and use it with, embeddings and vector storage and large language models too. Yeah, that sounds awesome.
Exactly. And just to give it a little bit of background, I think in the beginning, it was almost like a design project, and so if I had to give a little bit of intuition for what this design project consisted of, it's basically this idea that a language model is basically you can treat it as like a reasoning engine because you give it some natural language input and it'll give you back some output because it can try to give you back the best answer given what you tell it to do. In that sense, it's almost some sort of like AI-enabled CPU, right? And then if you think about the rest of the computer architecture that you need to build a full program, you're going to need some sort of like RAM or hard disk space to actually store stuff, right? That you can basically have the CPU interact with. And so for me, I was very interested in building some sort of data structure where the language model could actually reference some sort of like external memory or hard disk space, if you will, so that it could leverage, it could try to look up information that wasn't previously in its own knowledge base and try to retrieve that for the user, depending on the query that they asked. It was this like big design project, and I think as users became more interested in it, I had this moment where I thought, oh hey, like I should actually use a lot of the existing techniques and not try to reinvent the wheel, and actually just try like baking a lot of the existing stuff into this toolkit that people could easily use to again store and use their private data with a language model.
Awesome. Yeah, that's really interesting. So many parts that are coming out right now that are, you know, I think the integration and piecing all of it together into kind of like you're saying a full stack AI operating system or something like that is really exciting to
Mhm.
see
Exactly.
the development of. How does it outline in the framework of LlamaIndex these different pieces?
Yeah, so I would say I actually don't know if there's a proper computer analogy, but I think at its basics, you can think of it as just a really good tool to just manage and query your data and use it with a language model. The idea here is that the key problem that I want to outline is, let's say you're just an individual or you're an enterprise, and so you either have like a collection of notes on your hard drive, right, or you have an entire data lake with just like thousands of or like gigabytes to terabytes of different types of data, like structured data, unstructured data. And regardless of whether you're on either one of these spectrums, you want to figure out, okay, like this language model technology is amazing. How do I use this on top of data that is private to me that it inherently doesn't know about, right? And so just like kind of taking a little bit of a step back. These days, there's basically kind of like two camps for figuring out how to bake knowledge into the language model. The first is this idea of like fine tuning or training or distillation, where you are a machine learning engineer or researcher that knows how to build these models. You actually initiate some sort of training process on top of this data. So that the model itself can actually just memorize stuff, right? It can like memorize the data that you give it. And so that's basically how you train one of these large language models in the first place. Like if you look at ChatGPT and you ask it anything that's like publicly available on the internet, like any Wikipedia page, like ask it about apples, about the American Revolution, like any of those things, they'll be able to know the answer, right? Because that stuff's like all kind of publicly available. It was in the training data. Mm-hmm. But for your own private data, you can also initiate a process like called fine tuning, where you can actually fine tune these models on top of your own private data. And these days, there's like downsides to doing that. A lot of fine tuning efforts don't quite work. A lot of people don't really know how to do fine tuning. You have to prepare your data in a certain way. There's a certain like kind of expertise level required to do that. So the next kind of thing, the next camp that people are kind of like going into in order to boost their language model with private data is this idea of in-context learning, or like retrieval augmented generation. You fix the language model itself, so you just use it out of the box, but then you couple it with like a retrieval model on top of your data, and basically build this entire system where you're just treating this language model as like a processor, and you're coupling it with some other thing that's able to go and retrieve your data and then put that data into the input prompt. And so basically, just at a high level, a language model is very good at reasoning, and so what you can tell the language model is essentially, hey, here are some new data that you haven't seen before. So here's some context, and you dump the context, and then given this context, here's a question, and then you give it a question, and then given this context plus the question, please give me an answer, right? And you can tell like ChatGPT or any language model this entire sequence of text, and then it can like try to figure out the answer for you. And so you can actually use it as a strategy to operate on top of your own private data. And that really is what like LlamaIndex is designed for.
Yeah, it's amazing. I mean, I've been doing this now, and I spend at least an hour a day talking to one of my bots that is trained on my data, and I'm constantly thinking of, oh, what do I want to learn this week? What should I add, into the embedding to be able to learn on? So I think it's a really powerful way of learning and creating content and querying your data. So could you talk a little bit more about, that was a great high level overview on bringing
Yeah.
in your data. What about, I know one question that a lot of people have is, what
Mm-hmm.
kind of data do they need to put into it? So you talked about unstructured versus structured data. People ask me a lot, what file types should I, what format does the document need to be in? Or, these areas of how do I start to get my data into a system like this?
So that's a great question, and honestly, I could talk for like an entire hour about this, but just I hope to like distill some of this down to the users. There's something very beautiful about language models in that they can basically just take in unstructured text as like a central medium of data representation, and they can understand unstructured text very well. And so, just to give you an example, if you take a web page, right, and maybe just do some basic processing, like you strip out the HTML tags or something like that, right? And then you just like dump the entire web page into the input prompt of the language model, assuming you obey the prompt limitations, but this is just an example anyways. It can understand that web page, like the entire thing, even if there's like messy formatting and other stuff going on in that thing that you give it. And so you don't really need to write a ton of like manual parsing to like process or clean the data. And like if you look at kind of before language models, like how you set up like a data pipeline, you need to do a lot of like complex like ingestion, parsing, ETL, and then you store it maybe in like a structured format. Then you annotate this like unstructured data with a bunch of tags, and then you use these tags to help like gain insights over your data. One of the cool things about language models is you just give it unstructured data. It can like just process the entire thing, like chew it up, and then just figure out basically what the answer is. And so if you have something that powerful, it kind of implies certain things about like the setup that you're going to use to basically and the types of like file formats that you can ingest. Because you can pretty much ingest like any file format, like PDFs, PowerPoints, Excel sheets, anything, as long as you can just convert it into a text representation, an unstructured text representation that the language model can understand. This includes like images or videos too. Like if you have images and you can caption that image using some piece of text, or you have a video and you have a description of that video using a piece of text, then you could totally just like index the video and ask questions over that video too. And so what LlamaIndex actually supports is we have this site. So just to give you a sense, we have three different components. One is just data connectors called Llamahub, where we offer over 80 different data connectors, or actually I think it's over 90 at this point, that allow you to connect all these different data formats, APIs, like workplace apps, structured databases to your system. And you can just ingest this data. And then the next steps, like steps 2 and 3, are basically just like indexing, storing this data, and feeding it to the language model. And so it's actually pretty powerful. Like we support being able to ingest like PDF files, PowerPoint files, Excel files, like image files, like websites. We have like 5 or 6 different web scrapers at this point. And a lot of this is community driven too. And I think one of the first things people realized with language models was the fact that you could pretty much feed it like any data as long as it was text, and it could like try to understand it. And then there's, as a result, there was like a ton of cool applications being built on top.
Absolutely. I think that's huge. Both that and what you mentioned earlier about the difference between fine tuning and training and the context retrieval. The fact that, it doesn't require as much experience to like formal ML experience to be able to do some of this contextual embedding, and then also being able to not have to format the data and, know how to do all the machine learning for that is really allowing so many more people to use these tools. And I think that's a huge part of why we're seeing an explosion in this area, that now, machine learning is becoming a lot more accessible to people in enterprises and in front end development and lots of different areas.
100%. And I think it's interesting because it covers like a spectrum of like kind of technical expertise. And what you're seeing these days is if you're kind of like a user that has less AI experience, using a tool like LlamaIndex, you can get up and running, building a chatbot over your data in 3 lines of code, right? Ingest the data, index that data, and query that data. And the reason you can actually do that is because of, again, the fact that language models have radically simplified this like data ETL stack. You just dump in the data, index it in some light format, and then you can just start asking questions over it. But I think the key is also there is like an entire spectrum of like technical complexity that more kind of like sophisticated AI experts are also trying to solve. And I think the key is also making sure that our toolkit captures the functionality and the extensibility and customizability necessary to allow them to kind of like play around with these pieces as needed.
Definitely. And on that point, I want to ask a clarifying question that I think people have, which is, can you clarify a little bit that's great. I didn't know it was only 3 lines. That's amazing. So you have the data connector, the indexer, and the query. Could you elaborate a little bit on what an indexer is and kind of more of the process of feeding the data into the LLM or giving it to the LLM?
Yeah, totally. I think when it's like 3 lines of code, it does feel a little bit like magic. But the all these steps you can customize yourself to. But basically, as you said, there's the data connectors where you load in the data from, say, a PDF file or a text file, and you just, or anything that we just talked about, like PowerPoints, databases. You load it into a document object, and this is a very light document object. It's just like a thing that stores a bunch of text and maybe some metadata. Then you want to index this document, and what indexing basically means is there's a variety of index structures that we provide. The most basic one is you basically chunk this text up, and then you add an embedding to each chunk, right? And so you chunk this text up using some sort of like text splitting strategy, and then you add some sort of embedding, which is basically a vector of numbers to each chunk that semantically represents what that text chunk is about. Now you have basically stored this, right, in some sort of vector store. And, we offer integrations with different types of vector store providers like Pinecone, Weaviate, Chroma, like Milvus, et cetera. And then once you actually have this, then you can query this data, right, because this data is stored in a vector store. And the way the query works is you ask a question or you give some tasks to solve. And then we would first retrieve the relevant pieces of data from this index using because if they're stored with embeddings, you use like top K embedding similarity lookup, and then you retrieve the most relevant text from your corpus. And then you feed these texts to the language model to synthesize the final answer.
Awesome. Okay, I have two follow-up questions on that. I think retrieval is becoming a really important concept. Could you talk a little bit more about what exactly retrieval is and how it's relevant to this process?
Yeah, so let me tell you a little bit more about this system of kind of like retrieval augmented generation. And so it's a pretty fancy term, but basically the high level is you have a language model, and then you have this other model called a retrieval model, and then you have your data corpus. When you have an input request coming in from the user, like an input prompt, you would first retrieve the relevant pieces of text from your knowledge corpus using this retrieval model. And it could be a variety of formats, but the high level is that it takes in some query and it gives you back a set of relevant retrieved text. And then you couple that with some sort of synthesis model or generation model. Once you have the retrieved text, you feed it to this generation model, and this generation model will, synthesize the final answer for you. So the generation model is basically the language model. The language model is this thing that can, take in a bunch of text and then like synthesize an answer for you. Now, the retrieval model could be one of a variety of different things. These days, a lot of people are using vector stores to basically store and index their data. So the retrieval model, what it does is it just does like embedding based similarity lookup of your data over the vector store. Like it'll take in the input query, get an embedding for the query, use that embedding to look up the top K most similar documents from your vector store, and then use that as your set of retrieved text. It's interesting. I think there's becoming like more and more different types of like retrieval too. For instance, like if you want like a keyword lookup or like a knowledge graph lookup, you could use kind of like relationships between entities within your knowledge graph or in between like different nodes to also do retrieval too. So you could like fetch like not just the current node, but also like relationships between nodes too. We have a variety of these types of index structures within LlamaIndex that allow for different types of retrieval. Another very interesting thing is that, like retrieval is not a new concept. Like this thing has been around for a while. Like if you just take retrieval on its own and, strip away the language model, it basically just gets into kind of like, how do you best do like information retrieval and recommendation systems? And so there's a lot of concepts that you can add here too, like maybe a first stage pass of retrieval. That's like, you first get back some initial bucket of items, and then you filter it out through some second stage pass, like some rewriting or filtering step. That could be its own retrieval system. And so retrieval itself is actually quite interesting. There's like, a decade or multiple decades of research going on here. But it's also interesting seeing the interaction between the retrieval model with the generation model, because this entire system is the thing that gives you back the final answer that you would want.
Oh, that's very interesting. And you actually kind of answered part of my second question, which was getting into what if people that are working in enterprises already have structured data rather than unstructured data. And my question
Mhm.
was going to be, can you do something maybe on the indexing and chunking level where you're organizing how the information goes in to modify, the relationships based on the structured data? But then you kind of mentioned that you could also use the retrieval step to create some sort of structure, because that's something I've run into with my clients, is that sometimes there's a spectrum. Sometimes you just want to,
Mhm.
query a long document and see what you can get because you haven't read 10,000 pages of, you know,
Mhm.
um, compliance documents, and being able to query them is a great way to do the initial research. But then sometimes, enterprises have significant infrastructure already in place, data infrastructure that has specific structure. So, yeah, what do you think about people that are already have that data and maybe want to build a more, like you said, sophisticated system?
Yeah, so the part that I actually probably didn't talk about was, the retrieval happens from something, and that something is like a database. So like a unstructured, there's different types of databases, right? There's like unstructured databases like key value stores and like vector stores. Those will fetch like unstructured documents, if you will. And then there's like structured databases, like stuff that you could query with SQL. So those kind of inherently like necessitate like different forms of retrieval. So actually, probably like for if you already have a bunch of data in like a structured table and you want to query that with natural language, what you can do is you can run like text to SQL on the structured database. So for instance, you have this input request coming in from the user, you have this structured database, you can take this natural language input, and you wouldn't do embedding based retrieval. You can actually prompt the language model to output a SQL statement that you can then execute against the structured database, and then you get back the set of results that you want. So I think that the retrieval mode kind of inherently depends on the interface that your data exposes. So if it's a structured database, it would probably expose some sort of like SQL query interface. And then if it's like a vector store, for instance, it would expose like a top K embedding lookup interface, because that's more for retrieving like unstructured documents.
Oh, interesting. That makes a lot of sense. Okay, thank you for explaining that. So you mentioned earlier, and I've seen this website before, and I think it'll be really useful for people to see. You were talking about you have 90 data connections, and that website's just awesome to look at. You just see you can see all the cards and just tell how much amazing functionality is. Could you just mention what that web page is, and I'll put it in the description so people can check that out?
Oh yeah, for sure. It's called Llamahub.ai, and the website was actually designed by a contributor, so I want to give him a little bit of credit too. His name is Jesse. But yeah, it looks nice. There's over 90 data connectors on there, and if you're interested, we're always open to contributions too.
Awesome. Yeah, it looks great. Good, Jesse. Jesse crushed it. So there's the data connectors on there. You also mentioned that you have multiple retrieval mechanisms. Is that on the LlamaIndex documentation where we would find the different retrieval methods?
Yeah, so we have an entire like kind of pretty principled architecture detailed around this idea of like retrieval augmented generation. There's a few guides on there in the Llama Index documentation. You could Google Llama Index docs, or that's basically our main website at the moment, up until we actually have a landing page. And so we have a few guides on how that works. But the idea is that again, you once you actually load in this data, you want to index and store this data using some sort of like database or document storage. And then once you store this data, you can do retrieval over this data and then synthesis over the retrieved data to again build this like overall query interface to give you back the result that you would want. Um, we have like different retrieval methods corresponding to the different index structures that you want to build. We also have additional retrieval methods corresponding to some of the more advanced stuff that I described. For instance, like being able to do re-ranking, or being able to kind of like use the LLM to like route a query to different types of kind of like sub data structures, or like kind of like you have like a variety of different indexes, and how do you like route a top level query to the different indexes.
Oh,
And so
interesting.
all that stuff's in the documentation. I would definitely check it out. I think hopefully the idea is that to get started, you can do something super easily, and then if you want more advanced functionality, you can the docs should be able to expose that as well.
Yeah, I think, yeah, what you just said, going back to kind of the operating system model, being able to dynamically switch between different retrieval mechanisms, or different data connectors or different embeddings to like change the personality or memory of the bot, I think would be really interesting. And, something, yeah, seeing these kind of full-fledged systems where you can choose maybe what model to use and all the different parts can be changed depending on the task is really interesting. So
Mhm.
okay, going back to a little more basic on how people can get started. So LlamaIndex is primarily Python library right now, right? So can you talk a little bit more about what environment? Let's say someone wants to get started, they want to use the 3 lines of code, basic version 1, to start
Mhm.
connecting their data to LLMs. Can you talk about, where is this? How do they start coding this? Is it going to be in their command line? Is it going to be in a web browser? What's the best way to get started environment and yeah, coding wise?
That's a really good question. I'm glad you asked that. So LlamaIndex is a Python package right now. It's publicly available on PyPy, so you could pip install LlamaIndex. At least in the quick start tutorial and a lot of the examples, it's basically it's showing you how to write like a simple Python script, either by itself or in a notebook that you can just run. And so if you run it in like a Jupyter notebook, you could just run each cell and you'll be able to visualize the results in a notebook. Otherwise, you could write it in a script and run it in the command line. So that's just the very basics. That said, we actually do have tutorials for how to integrate this as part of some, full stack web application too. And so if you look through the tutorials, there are a few of them that show you how to build a full stack web application. We also have like an adjacent repo made by a contributor called like the LlamaIndex starter pack, which shows you how to actually package this thing like your application, which is in Python, as like a Docker container or as part of like a Flask backend, so you could query it from some sort of client front end and build like a full-fledged application from it.
Awesome. And is the previous one, not the starter pack, but the other web application guides, is that recommended in Flask as well?
um, I think it's in Flask. Let me actually double check, but I'm like 80% sure it's in Flask. Yeah.
Awesome. Awesome. That sounds great. Um, yeah, I think that is, we like you said, we could talk about this data formatting and everything for an hour. Maybe we could do a follow up. I know we've discussed doing a follow up, maybe helping people start coding with this a little bit more. But thank you so much for answering all these questions and helping people get into this and building this amazing tool. And congratulations too on its growth into GitHub. It's amazing that this is becoming such an important topic for people. And I think LlamaIndex is one of the best tools right now to help people get started with that. So congratulations on building this. And before we kind of wrap up, is there anything else that you would like to go over, or where people can find you and get started with LlamaIndex, or things that you're working on and looking forward to?
No, I mean, yeah, thanks, Dylan, for the time. I really enjoyed being here. And if you want to reach out, there's a lot of links in the documentation to the Twitter, the Discord. We have an active Discord community. So if you play around with LlamaIndex and you ask any questions, please feel free to reach out on one of the channels. And there's just a lot of discussion going on in it.
Awesome. Sounds great. Well, thank you so much, and hope to have you back soon. And I'll keep in touch and looking forward to LlamaIndex growing. So thank you again.
Thank you, Dylan.
Awesome.